All right, guys, so today we're going to start section 9.2, which is your learning target is that we want to be able to graph quadratic functions in the form ax squared plus bx plus c. If you look back at your learning target for 9.1, it's very similar to that. The only new thing about today's is that middle term, the bx term. All right. So when we throw in a middle term, it kind of changes things a little bit. And again, if we look back at our 9.1 examples, they were all, our vertex for all of those parabolas was on somewhere on the y-axis, right? So we talked a little bit about there being symmetry with a parabola. It's the same on both sides. So basically, that line that splits our parabola down the middle from 9.1 was always the y-axis. If you go back and look at them, the y-axis cut every parabola right in half evenly. Okay, but when we throw in that bx term, it's going to move around a little bit. Okay, so that would be the difference. This could be a pretty technically difficult lesson if we're not using Desmos. So, you guys pray for the other algebra classes who aren't using Desmos on this lesson. But we'll use Desmos, and so we can really get into the nitty-gritty details. That's what that'll allow us to do. All right, so one key thing that we're going to reference today is, like I said, that line that cuts our parabola in the middle, down the middle. That is what's known as the axis of symmetry, okay? So that's down here in this clipped out thing from the textbook. So here's our formula. I would highlight or circle that. X equals negative b over 2a. That is actually part of another formula we're going to end up using later in the year, or later in this chapter. And that is called the axis of symmetry. It's one of our vocabulary terms. So we're going to practice on using that today and Desmos. So without any other kind of setting it up, let's just go ahead and jump into it. Example 1 is all about kind of graphing these, okay? So that's what we'll be doing. Go ahead and start with 1a. It says, what is the graph of x squared minus 6x plus 4? Okay, so before we do anything with Desmos, I'm going to go ahead and we're going to practice using that formula that we just talked about, the axis of symmetry. So we'll kind of call this like step 1, which is the axis of symmetry step. Okay, so for that we say x equals, it's negative b over 2a. I'm going to shut this door. All right, so first of all, for b and a, you gotta know what those are. So let's go ahead just on our first one and say what a is, what b is, what c is. So a is our lead coefficient. So a equals 1 for this one. B equals negative 6. That's our coefficient of x. And c equals 4. Not that we need c for this formula. So again, negative b over 2a. So that would be negative, and then b is negative 6. So negative 6 over 2a. So that'd be 2 times 1. So I want you to try to type that in and see what you get. Just now that you have it written down, what is negative 6 over 2 times 1? Because that looks kind of weird with the double negative thing. It would make it a positive, yes. Two negatives, and that's a good generalization. If you have 2 negatives in your expression, it is going to end up being positive, yes. So what's it simplify overall to? Anybody have it? Yes? 3 is correct, all right? So we get x equals 3. So now the y-axis is no longer our axis of symmetry like it was on 9.1. Here's what I want you to do. I want you to draw a dotted line of x equals 3. So what that looks like is we go to where x equals 3 right here. And then we're just going to make a dotted line. We're just going to trace that grid line. So we make it dotted because it's imaginary. It's not really part of our graph, but it's more of a guide. All right, so now that we kind of know where the middle of our parabola is, now I'm going to go ahead and type it into Desmos. Okay, I'm going to type in the function just as I see it. Zoom in a little bit. All right, so I can see that at least my axis of symmetry appears to be correct. Looking at my graph, here's x equals 3, right? Kind of drawing my line right down the middle. And again, we can see that symmetry on both sides of my axis of symmetry, okay? So beyond that, we want to kind of figure out what our points are. So step 2 is we actually fill out our table of values, all right? So step 2 is we're going to make an XY table from what we see on Desmos, okay? So our first and most important point that we always look at with a parabola is the, anybody remember V word? Yeah? Vertex, very good. So our vertex is always, you'll start to see this, it's always on, let me make that a little bit thicker. It's always on your axis of symmetry, right? So if our axis of symmetry is 3, then our vertex is going to be 3 comma something, okay? That's a generalization that's good to make. So 3 comma what? It looks like 3 comma -5. Bless you. Okay, so that's going to be 1 on my table. I'm going to just write in the middle of my table, 3 goes to -5. All right, after that, then I kind of want 2 points on either side of my vertex to show that symmetry, right? So I'm looking for corner points. So it looks like from my vertex, I can go up 1 and right 1, and also up 1 and left 1, okay? So those points as ordered pairs would be 4 comma -4 and 2 comma -4. All right, so I'm going to write those in on my table. 2 goes to -4, 4 goes to -4. And then the last one, it looks like I have another corner point right here at 5 -1 and also 1 -1. All right, so I'm going to write those into my table. 1 goes to -1, 5 goes to -1. So again, in our table, we can see that symmetry, right? If we look at our y values, it goes -1, -4, -5, -4, -1, right? So we kind of see that turn back in our table. Now, this is a very common pattern, right? So if you graph like just y equals x squared, this is the parabola you would see, but it would start from right there. So from your vertex, a common pattern is you can go up 1 and over either way, and then you have your corner points. Also up 4 and then over 2 either way, right? That's a really common kind of pattern that you'll start to notice as you graph more and more of these, okay? Makes it easy to find your corner points. Do what? There are, kind of based on that, but we'll cross that bridge when we get there, okay? So the last thing, now that we've written these out, is I'm just going to copy the points onto my graph. If you've already done that, that's fine. So there's my vertex at 3 -5. And again, I know I go up 1 and over 1, you know, either way. And then from there, I can also go up 4 and over 2 either way. Then I'm just going to trace it as best I can. So now I have a very accurate graph using actual points that I see from Desmos. If it's tough to see, like, are these really a corner point? Remember, you can always go to your table, which is up there with the gear, right? You can click that, and you can type in whatever you want. Okay, so like, you know, we see 1 goes to -1, 2 goes to -4, but then you could type in your others as well. Okay. So any questions so far? All right. So then the last thing, you're going to have to say that if it's a comment for me. I can't see it over here. So if you really need to say it, say it. If not, I'll read it later. So the last thing is we want to list out the domain and range. Okay. So step 3 is the domain and range step. All right. Anybody remember from yesterday what is automatically the domain? All real numbers. Okay. That's the one that you don't have to think on if you just remember it. All right. My range has to do with my maximum or minimum value, which has to do with my vertex, right? So I'm looking at my vertex, and I can see that all values are either on my vertex or above my vertex, right? My vertex is my floor. So that means that all my y values are either equal to -5 or greater than -5, right? So we would say our range is y is greater than or equal to -5. That's the one where you have to think. Domain's pretty automatic. Range, you got to think a little bit, okay? Anybody have any questions so far? Anything sticking out? Yes? Give them what you got.
That's our floor. If the numbers are above it, then the y is greater than 0. But if
Greater than or equal to -5.
then y is less than equal.
So we talked about, we talked about the terms in our first lesson, maximum or minimum value, right? So if it opens up, then our vertex or our y coordinate of our vertex -5 is our minimum value. So that means all other values are above that, right? So again, you know, if I just trace the curve, thinking about my y values, here I'm above -5, still above -5. Still above. Here I reach -5, right? Are you looking, Grant? And then I turn back to go above, right? So everything's either at -5 or above -5, right? It never goes below -5, okay? All right, so let's move on to the next one, which will be example B. All right, so before we go into Desmos, let's find algebraically our axis of symmetry. We'll call that step 1. So it's x equals -b, so that'd be -4 over 2 times a, so 2 times -1. -4 over 2 times -1. I'll give you a second to punch that in, see what you get. Anybody want to say what they got? All right. Should get 2. Should get 2. All right. So I know there are 2 negatives in there, so it's going to be positive. And if we think about, you know, what we end up with, it's 4 over 2, right, which is 2. Okay. So x equals 2 is going to be the middle of my parabola, right? So I'm going to make that dotted line right here. It's just an imaginary guide to say that's the middle of my parabola. Once we have that, once we know where the middle is, now we'll go into Desmos. If you're following along, you're typing in y equals -x squared plus 4x minus 2. I'll just pull up mine. I already have that done. So here's what it looks like. I'm going to zoom in a space. And it looks like our x equals 2 thing worked out. All right, so that's good. Good to see when your algebra steps work well. So x equals 2 is right here. And we see it does go right through the vertex, right through the middle. All right, so the next thing we go to is to make our table. We want our table of values, okay? We always want our vertex right in the middle. So what is my vertex? 2 comma what? 2 comma 2, very good. So I'm gonna put that right there. Okay, and then I'm looking for other corner points. So this time, obviously, I'm not going to go up 1 and over 1 both ways, but I am going to go down 1 and over 1 both ways, right? Those are corner points. So it looks like 1, 1, and 3, 1. So now we're starting to see that symmetry on both sides. And then we're going to go from the vertex, we could go down 4 units and over 2 units either way. So that puts me at 4, negative 2, also 0, negative 2. All right, now I'm going to put those on my graph. I like to start at my vertex, 2, 2, and then I'll follow my pattern to get to 1, 1, and 3, 1, and then also 0, negative 2, and 4, negative 2. All right, so any questions about what we've done so far on this one? So just another interesting fact, maybe you noticed this or maybe you didn't. Remember, like for a linear function, we always looked at the constant as being the y-intercept. That holds true for this as well, right? So your constant at the end is negative 2. Notice our y-intercept is 0, negative 2. So that's another thing you can just kind of look at it and tell it's going to cross the y-axis at negative 2. But you don't always need that for this one. It just depends on where the vertex is. So no questions then. We'll just do domain and range. And then we'll see where we're at time-wise. All right, so why don't I give you about 20, 30 more seconds and see what you can do on domain and range. We'll see if you guys are picking up on that. Feel free to get it from a neighbor. All right, Peyton, what'd you get for domain? Very good. Okay, and you know, all my basketball fans right there, that would be like what we call you know, a layup. Like your coach always tells you, you got to hit your layups, right? So domain, if it's all real numbers every time, just remember it, right? And take your gimmies where you can get them in this class. Natalia, can you tell me what the range of this function is? Natalia G. All right. How about Grant? Range? You got part of it right. Y is less than or equal to was a good start. But like all in here, it's above 0, right? So it goes above 0. So what's my upper limit then? You know what it is, Grant? It's 2. That's right. So your maximum value or minimum value is always going to have to do with the vertex, right? So less than or equal to positive 2, right? Because in this case, positive 2 is my ceiling. It never goes above that, okay? All right. You guys feeling all right so far? Good to keep going? Okay. So we'll probably do one more from example 1. and close the book on this for today. We'll probably save those word problems for tomorrow. All right, so I am going to call on you guys for a little bit more help on this one, though, okay? So kind of just be ready. Stay with me. Again, feel free to get some help from a neighbor if need be. All right, so step one, I'm skipping example C. I probably won't work that one out in class, but it is on the filled out notes. If you want to try that one on your own, probably wouldn't be a bad idea. So we're skipping to D, looking at y equals negative 2x squared minus 8x minus 3. So the first question is going to be, what's my axis of symmetry? All right, I'll put you a clue up on the board. If you don't feel like you need one, that's a good thing. All right, so there's a clue on the board. Give you a few seconds to work that out. And you can use your calculator. Still, it takes some skill, right? Got to be able to type it in, right? All right, Robert, were you able to come up with what is our axis of symmetry?
Is it x equals negative 8 over 2 negative 2?
Well, I want it worked out. So I already put what you had. Shanna, have you simplified that? Negative 8 over 2 times negative 2? Shanna? No. How about Kevin?
I got negative 8.
It's not negative 8. That's all right. Shackelford, what'd you get? It is not negative 4. Yes? It should be negative 2. All right. So you can see that it's not as, I guess it's not as easy as just telling you to type it in. You got to figure out, how to correctly type it in. But here's what I would say. Here's what I do. Sign-wise, I just count up how many negatives there are. There are 3 negatives. That's an odd number of negatives, so I know it's going to be negative. Besides that, I'm just looking at 8 over 2 times 2 is 4, right? 8 over 4 is 2. So overall, negative 2. But again, you can figure out how to just type it in on your calculator. Also, you can cheat it by looking at Desmos, right? You can see where the middle is if you just type in the parabola. But it's good to know how to use that formula, okay? So now that I have that, we're going to go ahead and start to try to get our table of values put together. So I'll pull it up on my screen. It's going to be probably easier to see from your screen, so I'll give you a second to punch it in. But I'm going to ask you guys for some help. All right, so my first question is for Jalen. Can you tell me what my vertex is? What's my key point that is the vertex? Negative 2 comma what? 5. Very good. All right, negative 2 comma 5. We can see it right there. So we need that point. That's a key point. All right, so next then I can tell you what I'm going to ask you for are to basically fill in the rest of this, which would be negative 3 goes to what, negative 4 goes to what, negative 1 goes to what, 0 goes to what. Okay, so you may want to type this in on your own screen. I'll give you a second to do all that. You're trying to, again, fill out the rest of the table. All right, so I'm going to start calling on people. If you don't have it, just, I don't know, say pass or something. Taylor Batman, can you tell me what -4 goes to? -4 goes to what? What goes here? All right, how about Andrea? Do you have what -4 goes to? Okay. Robert, what does it go to? Do what? I think you're looking at the right thing, but is it 3?
It's
-3, right?
Yeah,
That's all right. So -4 goes to -3. All right, so that means that across from that, also 0 goes to -3. All right, and then the last question would be, what does -3 go to? So, anybody want to volunteer? What's -3 go to? -3 comma what? Robert, thank you. -3 goes to 3. Very good. And so across from that, also we can see that 1 goes to, or sorry, -1 goes to 3. All right, so then we copy that down on our graph. I forgot to write in the axis of symmetry, so I'm going to do that too. So remember, we kind of talked about that pattern of from the vertex, you could go up or down 1 and over 1, up or down 2 and over 2, or sorry, up or down 4 and over 2. Notice that on this one, it's kind of stretched out. Remember, we talked about those stretches a little bit? So if we multiply, if we have a lead coefficient that's not 1 or -1, notice it's stretched out. So we don't like go down 1 and over 1, we go down 2 and over 1 in either direction. We don't go down 4 and over 2, right? We go down 8 and over 2, right? So that's how those lead coefficients we talked about stretching it out, right? So that's what's happened on this one. But you can see how the pattern is kind of built on that original pattern. All right, so the last thing is going to be the domain and range, and then we'll kind of close today's video there. So based on our graph, based on what we've talked about, what is the domain and range? I guess I should say, what are the domain and range? Don't want to make any English teachers mad out there. So Kevin, what's the domain? All real numbers. And the range, Peyton, back to you. You know what the range is?
Y is less than or equal
Good.
to 5.
There you go. Good. Y is less than or equal to 5, right? Because that's my ceiling. That's as high as it ever goes. Five is my maximum value. Okay, I'm going to go ahead and end the video there. We still have our word problems that are on the back side that we'll do tomorrow. But I will, we'll do that tomorrow. We just don't have the time today.